This example relates to basic probability. The lecture would have explained to you about the rules for probability, why we need to worry about using probabilities to work out what's going on in finance. However, we start off with a univariate probability distribution. Now, this is a completely made up example, and here's my example. We're adopting a relative frequency approach. Now, the idea is that we looked at the returns on a particular stock or share, and we found that 3 times out of the last 30 periods there were a return of 20%, 10 times there was out of 30 there was a return of 15%, 15 times out of 30 there was 10%, and twice there was a return of 5%. Now, looking at these numbers, it's very hard to just eyeball them and try and work out exactly what is likely to happen in the future. And this is a completely made up, hypothetical, super simplified little example. If you've had real world data, you've got daily trades, prices going ups and downs, you'll be swamped under the information. So what you need to do is calculate descriptive statistics for the probability distribution, and that is what is done, explained in the lecture notes, and that's what's done here. So here are the same numbers you've got in your lecture notes. Okay, 20%, 15%, 10%, 5%. Here are the probabilities. 3 on 30 is 0.1. 10 on 30 is a third, or 33.333 repeat. 15 on 30 is a half, and 2 on 30 is 0.0666, etc. Now, to work out the mean or the average return, then what you do is you weight each of the returns by their probability. So that's a product of that and that, and you get each one of those in that way, and then you add them up. That's known as the expected return in finance. That's a 12% return. So on average, we've got a 12% return. Now, that's a single number to represent the distribution. Alternatively, what you need to do is you want to work out the measures of dispersion. Now, the measures of dispersion, the best one is the variance or the standard deviation. So what you do there is you look at, that is the difference between the return of 20%, B1, and the mean of 12 points. So that's a measure of dispersion, and that's each one of those. Now, the problem with a measure of dispersion is some of them are positive and some of them are negative, and so if you add them together, you end up cancelling out. So it doesn't give you a good measure of dispersion. So what do? You square them. You can see that's squared because that gets rid of all the negatives. So you square them, you get that. Okay, they're all positives because you square any negative number, you get a positive. You square a positive number and you still get a positive. We weight them by their probabilities. Okay, so that's that multiplied by the probability up there, and we add them up. That's the variance. That's a measure of the squared deviations from the mean. One thing that you're going to want to do, though, of course, and that's down here. There's your variance. The problem with the variance is that, of course, it's squared deviation, so we also will then work out the square root of that, and therefore that is an easy to interpret thing. The standard deviation, of course, is simply the average difference from the average. I'll say that a couple of times. It's the standard deviation is the average difference from the average. Now, the other measures we need to worry about are the skewness and kurtosis, which are to do with the shape. Now, to work those out, you need to calculate the z values. These are the z values. Any z value is the deviation expressed in standard deviation units. So that's simply going to be the deviation, which is B4, which is that, divided by the standard deviation units, which is this down here. And then to work out skewness, we raise that to the power 3, or make that into the third moment of the distribution. That's the measure of skewness. We have a positive measure of skewness because the average of 12% is being dragged up by a few high returning periods. Okay, up here. And we also measure kurtosis. Kurtosis is the fourth moment of the distribution to the power 4, and that relates the distribution, the actual distribution, to the normal distribution. All of these things are expressed down here. The other ones I haven't mentioned is the median, which is the middle value with 50% above and 50% below. And you can see why the distribution is positively skewed, because we have an average of 12.3%. The middle value is 10% because the average are being dragged above. Okay, the mode is the most common, okay, which is the one with the highest probability of occurring. easy to work out. The range is the biggest minus the smallest. And that's all.